So hello and welcome back again to Carto Geospatial Solutions. So this video becomes a part of the Arcpy series. So in one of our previous videos, as you might recall, we did some vector-based analysis using the Arcpy language. So in this video, we're going to do some raster-based analysis using Arcpy. So what we're going to do here is that we're going to derive some variables from the DEM data, that is the data, like slope, aspect, and the contours. So we're going to learn how to do this using our Python Win application. So we're not going to do anything inside the RGIS software. So I'm just going to open it just to show you the variables which I got. So as you can see, this is my raster DEM data, and these are the variables that need to get, like aspect, contour interval, and slope. Okay, so we're going to see how to get these three variables from the DEM data using our Python Win application. So we're going to write the code for it. Okay, so let's get started. So let me open the Python Win application here. So in case if you're wondering what this application is and what its use is, I suggest you to please have a look at my previous videos in that I have discussed these details in depth. So please, you can see my previous video. So let me open the Python Win application now. So this is the Python Win application, and as you can see, this is the window in which we'll be writing the lines of code, and it can be saved as a file. Whereas this is the interactive window, in which you can see the output messages after running this code, right? So we're going to write the code here. So the first line which we're going to write is it's a very common thing. So we're just going to import all the Arcpy modules. So for that, it will be import Arcpy, right? And the next one is we're going to import the environment. So it will be from Arcpy import env, right? So now, since we're going to do some raster-based analysis, it is important for us to import the modules from the spatial extension toolbox, right? So for that, we have to include this line of code, which is from arcpy.sa. SA stands for spatial analyst. From arcpy.sa, import all. That is import space asterisk. Asterisk means all, right? So next we are going to set the workspace environment. So as I told you, our data was inside the tutorial folder, and which was inside the E drive, right? So we're going to write the appropriate folder path here. So it will be env.workspace is equal to open quotes e:/tutorial/Arcpy Raster. So Arcpy Raster is the raster in which I have saved the data. So it is e/tutorial/Arcpy Raster. So let me close the quotes here, right? So the next step is we're going to set the output coordinate system. So we have to project the data from the GCS to the PCS, right? So only then you'll be getting the accurate result. So for that, you have to set the output coordinate system. So for that, you have to write this env.output coordinate system is equal to arcpy.spatial reference. Okay, spatial reference open parenthesis. So in this case, you have to write. Inside this parenthesis, you have to write the EPSG code. That is the code which represents the zone in which your particular study is falling. Right. So for me, it is 326 double four, which means my study area is falling inside the UTM zone 44 north of the equator. Since my DEM data is falling in the state of Tamil Nadu, India, so this EPSG code stands for UTM zone 44 north above the equator, right? So you have to key in the appropriate EPSG code here based on your study area, right? So the next step is, since I have already created the data, I just need to override the output of the data. So if you want to override the output, you have to include this line, right? So it will be env dot override output. env dot override output is equal to true, right? The next done. So with this, we have completed all the basic steps here. So now we have to define the variables. So first, you have to define the input raster. So the raster which we are going to use, that is the DEM data which we are going to use to derive the slope, contour, and aspect. Right. So let me give the name as in underscore raster. Right, is equal to. So I have to key in the DEM data's name here. So since I've already set the workspace, it is okay to key in only the name of the DEM data, right? So my DEM data is within this folder, so I have to just type in the DEM data's name here. So my DEM data name is copy arc.diff, right? Okay. So I've defined my DEM data here. So the next step is we have to enable the spatially analyzed extension here. So in case if it is not enabled, you have to write a line of code which prompts the software to enable that particular extension. So for that, you have to write this line of code. So it will be arcpy dot checkout extension, open parenthesis, open double quotes, spatial, right? So this will be enabling the spatially analyzed extension in the ArcMap software. Clear? So now we have to define the variables which we want. So let me start with the contour variable. So let me give the name as contour itself. So I will just comment this one. So it will be contour. Right? So inside this, I'm going to define the parameters of this contour variable. So the first parameter which it needs is the interval. So let me give the name variable's name as cont underscore int is equal to. So I'm going to give the interval range as 200 meters. So each contour line will be 200 meters apart from each other, right? So let me give the value as 200 here. And the next parameter which we are going to define here is the base. So we're going to give the base as 0. So this base defines the origin. So it will be defining the origin from which it will be calculating the contour intervals. Say for instance, if you are just going to give the value as 20, so the contour interval will be mapped from the elevation of 20 meters to 20 meters to the highest value. Clear? So in this case, if I am giving the value as 0, then it will be taking the base value as 0, and the contour intervals will be increasing by 200 meters from 0 to the highest elevation of the data. I hope it is clear for you. So we have given the contour interval parameter and the base parameter. And the next one is we are going to define the output contour name. So let me give the name as op underscore cont is equal to. So here I am going to define the folder path in which it is going to be saved. So let me just copy this folder path here, and I just copy and paste it here. Right. So I'm going to give the name as con.sh. Okay. So contour contour parameters are done. We have given the we have defined the parameters as well as the output name. So you have to write the syntax which performs the operation. So it is contour, open parenthesis, input raster, output contour, comma, contour interval, comma, the base which we defined, right? So at this line we will be performing the contour operation, right? So we are done with the contour operation here. So let me move on to the slope operation. So let me just comment it as slope. Okay. So now you have to define the parameters for slope. So the first parameter will be the output measurement. So it will be asking us whether to display the output in the percentage form or the degrees form. Okay. So let me define the variable as output ms is equal to degree. So I'm going to represent the data in the degrees form. Okay. So it will be degree. Right. So the next parameter is the z factor. Let me give the name as z underscore factor is equal to 1. So since our data is going to be projected and as it is going to be represented in meters, so it is fine to give the z factor as 1. If you intend to transform your data units from meters to feet, then you have to give the appropriate conversion value. So since we are going to use this data in meters itself, it is fine to give the z factor as 1, right? So z factor will be 1. So now we have to define the output slope. So the output slope is equal to slope open parenthesis. So first variable will be the first parameter will be the input raster, and the next parameter will be output measurement. The next one is the z factor. Okay, so it will be input raster, output measurement, and z factor. So the next step is we have to save this output slope file. So for that, so it will be the variable which I created to save this, right? So it will be op underscore slope dot save, open parenthesis, and then you have to specify the folder in which we need to save this slope file, right? So let me give the same folder path again, right? So just open the codes here, then paste the folder path. So let me give the name as slope itself. So we can close this parenthesis here. So this variable which we created will be stored permanently as slope.tiff. Clear? So fine. So let me create the aspect parameters here. So it will be aspect. Let me give the name as output aspect. Output aspect is equal to aspect open brackets aspect of the input raster, right? So the input raster is the DEM data. So it is the aspect of input raster. And in the same manner, you have to save the aspect file. So it will be op underscore aspect dot save, open brackets, open double quotes, paste the folder path, give a name aspect.tiff, right? So given the output name for aspect as well. So we have created the parameters as well as we have defined the output part for all these 3 different variables, right? So the final step is, as soon as you do all these things, you have to just check in the extension. So just like what we did here, we're going to disable the spatial analysis extension now. So for that, you have to write this code. So it will be Arcpy dot check in extension, open parenthesis, open quotes, spatial. So this will be automatically disabling the spatial analysis extension, right? So you have just disabled the extension now. So next thing is we want to see the output message here, right, in our interactive window. So for that, you have to write a line of code here. So which states print dot arcpy. I'm sorry, print space arcpy dot get messages. Okay. So this will be giving us the final output after running this entire lines of code, right? So this will be giving us the message. So it is print space arcpy dot get messages, open and the close parenthesis, right? So with this we've completed the code. Well, let me just go through it again. Fine. I just made sure that there are no spelling errors here, because it is very important to check for spelling mistakes. Even a simple spelling mistake can create problems for you. So it's fine for now. So let me just run the code now. So before running the code, you have to just save the file. So I've already saved the file now. So let me just run the code. By clicking on this run button, you can run the code. So just give OK. So the code has finished running, and you can see the message here. It is saying that it has succeeded, and there seems to be no problem in the lines of code. And you can also cross check by going to your ArcMap software, and you can just refresh the folder. You can just see it for yourself. And in case, and as you can see here, we have got 3 lines of output messages here. So the first line says it has started executing the tool, and it has, and the second and the third line mentions about the start and the end time. So suppose in case if you want to see only the final line of message here, like this, and you do not wish to see all these lines of output messages, there is a way for that. So for that, it's very simple. Just have to create a new variable. So let's say create a new variable in the name msg count, meaning message count. So msg count is equal to arcpy dot get message count, open and close parentheses. Okay. So what it will be doing here is that this message count variable will be storing the total number of lines of output messages. So say for instance, in this case, we have got 3 lines of output messages, right? So this msg count variable will be storing the value as 3. Since it has got 3 lines of output messages here, so this variable will contain a value of 3 here, right? So now what we're going to do here is we just wish to see only the final line of the output message here. So for that you have to just write this line. So it will be print arcpy dot get message. Mind you, it is get message. Okay, it is not get messages. It is get message. Open parenthesis. MSG count. MSG count is a variable which we created. So it is MSG count minus 1 and close parenthesis. Right. So in this case, it will be printing us only the final line of the output message. So it will be assuming this final line to have a value of minus 1, and the line above that has minus 2, and so on. Okay, so it will be -1, -2, -3, etc. So what we have asked here is that we have asked the software to represent only the final line of the output message. So it will be displaying us only this final line of the output message, right? I hope it is clear for you. So let me just comment out this particular statement. Okay, so you can just comment this out. Okay, so let me save it again, and then we shall run the process again. Code has finished running, and you can see the difference between these two lines of output messages. So the first one was for the previous line of code, for which we had 3 lines of output messages, and whereas in this case we are able to see only the final line of the message here. So it is because of this code which we are getting this message. Say for instance, if you have written this written -2 instead of -1, then you will be getting this start time line of output message. Okay, instead of this succeeded one. Okay, so I hope it is clear for you. So with this, we have come to know how to do some raster-based analysis using the Arcpy language. So I hope this video was useful to you. So please do like, share, and subscribe my channel. It will be of immense help for me. So thank you so much for watching, and please do keep tabs on this channel for any future updates. So thank you so much again.